So in this video, we're going to learn another part of a triangle, which is called the angle bisector of a triangle. So your objective is that you can draw and identify the angle bisectors of a triangle. You know how to apply theorems from the angle bisectors of a triangle, and you can state and find the incenter of a triangle, which, remember from the last video, we had the centroid, and now our new term is the incenter. So what is an angle bisector? An angle bisector is a segment, line, or ray that divides the angle in half. So it goes through the middle of here, so I can draw one of the diagonals. So right there is a segment, angle bisector. So since it's bisecting, it means this is congruent to that. Bisect means half, cutting something in half. And we're going to learn about different types of bisectors. So knowing that, let me show you something here. I have created an angle bisector, and you can tell angle BCA, this angle right here, is congruent to angle CBD. So when I move them, they stayed the same. Well, because of that, there's some important theorems that can happen. The first one we're going to look at is that I'm going to create a perpendicular. I had too much selected. So construct perpendicular lines through here and find my intersection point. And then I'm just going to make a segment from here to here. Alright, so notice I made like a dashed line, and we're actually going to hide the perpendicular line. So I just want that segment right here. Now this right here, this angle here, is 90 degrees. Alright, and then I can do the same thing over here. So we're going to construct a perpendicular line. Oh, too much selected. Alright. Find the intersection of them, and then I'm going to make a segment that goes between the points. Alright, so then I have two perpendicular lines, and then I'm going to actually measure the length. So the length of that is 3.31, and then the length of that So notice that these two lengths are the same. Now the big thing is that it needs to be perpendicular. I had to draw a perpendicular line, so this is a right angle right here. And as I make them bigger or smaller, notice the two lengths are the same. So they are equal distance as long as they're perpendicular to the side. It's a very important theorem, and it has to be an angle bisector. So if you have two lengths the same length are perpendicular, that means there's an angle bisector, or the angle bisector indicates this. So it's a biconditional. It works both ways. Alright. So what that theorem says, and I have it right here, if the point on the bisector of an angle, so we have an angle bisector, that is equal distance from the two sides of the angle. And again, the big thing is that they have to be right angles. So this and this are congruent. Alright, so using that theorem, we're going to find the measure of GHFJ. Well, notice we have right angles, we have two congruent sides, which implies that F ray FJ is a bisector. So that makes this 42 degrees. So then on the next one, notice we have an angle bisector. It's perpendicular, which makes these two congruent. So from there, sorry. Grab my pen back. Alright, so we have 5x equals 6x minus 5. Alright, and minus 6x over and get negative 1x equals -5. Divide by -1. X equals 5. Alright, so again, the big thing is that they have to be perpendicular, or it has to be an angle bisector and perpendicular, then the two sides are congruent, or if you have a perpendicular and the two sides are congruent, then it is an angle bisector. It works both ways. Alright, so then you have something called the angle bisector of a triangle. So we're going to bisect the angles of the triangle. A raised segment or line is going to divide it in half. So let's draw that on here. So I'm going to bisect this angle best I can. So if that is a true angle bisector, that means this is congruent to that. So how many angle bisectors does a triangle have? Well, I can bisect this angle, this angle, and this angle. So since a triangle has 3 angles, there are 3 angle bisectors. So now let's go back to Sketchpad, and we're going to look at another theorem. So on here, I constructed the angle bisectors of a triangle, and take a look what happened. We have another point of concurrency. All 3 of them intersect at that point. Alright. Video.